Greetings and welcome back to the module 4 of spectroscopy, Nmr Spectroscopy. The objective of the session is to understand the principles of Nmr spectroscopy. The session outcome: the learners will be able to explain the principles of Nmr spectroscopy. Before going to the principle of Nmr spectroscopy, let us rewind the module 1, 2 and 3. In the module 1, we have learnt the electromagnetic radiation and its types, and the study of electromagnetic radiation interaction with matter is called spectroscopy. In the module 2, we have learned the different types of spectroscopic techniques, namely atomic spectroscopy, molecular spectroscopy, absorption spectroscopy, and emission spectroscopy. And in the module 3, we came to know the dissimilarity between the nuclear magnetic resonance spectroscopy, which is considered as a molecular spectroscopy, with other molecular spectroscopy techniques like UV visible and IR spectroscopy. We came to know three different dissimilarity between the NMR with other molecular spectroscopy, namely the magnetic field are used to split the energy states, the interaction of electromagnetic radiations with the nuclei, flipping of protonic spins used to take place in the NMR spectroscopy. And in this module 4, we will see the basic principle of NMR spectroscopy. The name implies nuclear magnetic resonance, which is represented as Nmr spectroscopy, clearly explains the interaction of electromagnetic radiation in the nucleus. Magnetic fields are used to create energy levels, so magnetic term is there in the name, and resonance, which will be discussed in this module. Hence, they have named as nuclear magnetic resonance spectroscopy. The NMR spectroscopy is based on the measurement of absorption of radio frequency radiation by a nucleus in a strong magnetic field. Very simple principle. Magnetic fields are used to create energy levels because in nucleus we don't have low energy, high energy levels. Radio frequency radiation is the electromagnetic radiation. Nucleus is the matter. Magnetic fields are used to split or to create energy levels. This is an example of absorption spectroscopy. And now let me state the principle of Nmr spectroscopy, which is based upon the measurement of absorption of radio frequency radiation by a nucleus in a strong magnetic field. Now the question is, what this magnetic field does in the nucleus, which was studied by Siemens, hence they have named as Siemens Effect. Generally in the nucleus, protons and neutrons used to be there. Neutrons are not charged, whereas protons are charged. When a charged particle such as proton spins on its axis, it creates a magnetic field because the spinning of charged particle will create magnetic field. Thus, the nucleus can be considered as a tiny bar magnet. Normally, these tiny bar magnets are randomly oriented in space. However, if we apply the magnetic field, they are aligned parallel and anti-parallel to the applied magnetic field. The alignment of tiny bar magnets, namely the charged protonic spins to the parallel, is considered as low energy state. The anti-parallel protons are considered as high energy state. It is discussed in the image. This is considered as a tiny bar magnet which is on spinning. Due to the spinning, the magnetic field is induced. In the absence of magnetic field, the tiny charged particles are in random orientation. Hence, it is called as degenerate. That means all the protonic spins are having same energy. If we apply the magnetic field, the degeneracy is lost. It is called non-degenerate. The degenerity is lost due to the application of magnetic field, and this plus half is denoted because the induced magnetic field of the proton are in parallel with the applied magnetic field, which is considered as low energy state, and the induced magnetic field of the proton opposes the applied magnetic field. It is given as high energy state. The energy difference delta E is very small, that is less than 0.1 calorie. This was studied by Siemens, hence this effect named as Siemens Effect. We are clear that the magnetic fields are used to create the energy levels in the nucleus. Because nucleus doesn't have any energy levels for excitation, we have to create the energy levels by applying magnetic field. Next, why the energy states splits into two? Because the spin quantum number I, which you people have studied in your first year, first semester, the spin quantum number I for H1, that is hydrogen, is half. Therefore, if you substitute that I value in the number of spin states formula, 2I plus 1 is equal to 2 into half plus 1 is equal to 2. Hence, two states are produced if you apply the magnetic field into the protonic, that is hydrogen nuclei. Next question rises, why the resonance term comes in the name. If the radio frequency radiation which we are irradiating to flip the protonic spin from the ground state to the excited state to takes place, at its resonance, this particular process used to take place. That is what it is clearly represented in the slide. If radio frequency radiation irradiates, the flipping of protonic spin takes place at a wavelength that coincides with the energy difference, is called resonance. So the flipping of proton takes place at a wavelength which coincide with the energy difference. So that energy difference is due to the magnetic field, and the flipping of protonic spin between the energy levels is due to the interaction of radio frequency radiation. These two will be having same energy, then it is called as resonance. Therefore, by measuring the signal which matches this transfer, the processing is called the NMR spectrum for the concerned nucleus. Excitation mechanism of Nmr spectroscopy, very clearly represented in this image. Initially, the nucleus spins are degenerate if you apply the magnetic field. Spin states are created into two due to the formula 2I plus 1 which we have discussed before. If we apply the radio frequency radiation which is equal to delta E, then the flipping of proton used to take place. Here the plus half spin will going to flip into minus half spin, or minus half spin will going to flip into plus half spin used to takes place upon irradiation of radio frequency radiation. That is why it is called as flipping of protonic spin. Hence, the interaction of electromagnetic radiation with the nucleus is taken place. That is why in the name it is given as nuclear. Magnetic field is used to create the energy levels. That is why it is included in the name. And the flipping of protonic spin used to take place at resonance. That is why it is also given in the name, that is called as nuclear magnetic resonance. C12 is NMR inactive. Why? Because the spin quantum number of carbon is 0. If you substitute in the formula of number of spin states, then it will going to have only 1. Hence, no Siemens splitting takes place and no absorption of radio frequency radiation is possible. Hence, as an important note, nuclei with odd mass number are NMR active. Example, hydrogen 1, C13, etc. Other even mass numbers are NMR inactive because their spin state are 1. Thanks for your active participation. Kindly attend the online session in a Google Meet platform for any clarification if you have. Thank you very much.